this quadrant it is A, S, T,
All students take calculus.
all students take calculus. Right? What does this mean?
That means shows you if x and y are cosine and sine or positive.
Here
or negative.
cosine is
Positive.
positive.
It's showing you.
So this is, what is this angle?
That's 90.
90 degrees. Right? This is
100.
92, 180.
Yes.
This is 182, 270. Right?
Mm-hmm.
And this is 272, 360. Right? So it is all students take
Calculus.
calculus. So here it means all are positive.
Right.
So what that means is cosine, we start with sine. Okay? Sine 0 to 90 is positive. Cosine 0 to 90 is positive. Tangent 0 to 90 is positive. You with me? Here only sine is positive, which means sine of 90 to 180 is positive. Cosine is negative, tangent is negative. You got it? Here it is, only tangent is positive. Cosine and sine are negative. Here only cosine is positive. Sine and tangent are negative. Alright? Now, look at this problem. If I give you this matrix, and if I give you this matrix, this is a result of problem 1. The direction cosine matrix or the rotation matrix is a consequence of rotation 313 by angle cap omega I small omega, right? If I say that rotation matrix is given by C equal to those 9 numbers, and I ask you to, so try to understand the context of 7a. Alright? What is the classical Euler angle sequence? We discussed this. Keep your cell phones away, please. 313 omega I cap small omega. Okay, that is the classic Euler sequence. Okay. Classic Euler sequence will always be this matrix. Got it? If you provide values to I or cap omega I small omega, will the matrix look something like this? You with me? If I give values to cap omega, numbers, to cap omega I small omega, the matrix will reduce to something like this, right? You understand? So if I give you this matrix and say calculate the angles, knowing that this is a result of a classical Euler sequence, where do you start?
You can take the first element of the first matrix and set it equal to the
Right. That's what you do, right? You understand?
Oh.
But which element will you specifically take?
bottom right.
Huh?
Bottom right.
bottom right. What you do is, you do cosine I
Equals negative
equals negative
0.4331. And take the
right?
cosecant.
Where is this angle?
It's in either second or third quadrant.
0.4301,
301.
right? So I will be,
You do the second or third one.
it will be either here or here. You agree?
Mhm.
And you can find out cosine inverse negative 0.4330.
Sorry, sir.
Hmm.
Why did you start at the bottom right?
Yes, that's a good question. Why did I start at bottom right?
Is that the easiest way?
It's the easiest one.
Okay.
It's straightforward, okay?
Wait, why is it straightforward? Why is
There's
it
only one angle. 'Cause if
It's
you look-
one unknown, one equation. But this is not going to yield you. How many values is this going to yield you?
Just the I, but you can use the bottom.
It's going to yield you two values. Keep in mind. Cosine of I is also equal to cosine of negative I. Okay, so I is also this, negative I is also you get it? So what do you do with this? You cannot, can you decide which eye to take?
No.
You cannot, right? You see, does it matter which eye you take?
Yes.
It matters, right? Your orbit will flip. So what you do is,
when you point into any of the others that uses an eye and see what that yields. So like if you took negative sine I cosine omega, solve for omega, and then try using the other eye, use one of the eyes first and then try to
typically,
see what it yields.
eye has a range. Okay? I need you to understand what that range is. What could be the range of I? What is the least value of I?
90?
Least value of I?
0.
0. What orbit is that?
That's a very
It's a circular one. Or
If I is 0, what orbit is that? Guys, please put your cell phones away. What kind of orbit is that? What is it called? Equatorial orbit? You agree? If I is 0, it's an equatorial orbit, right? Equatorial orbit.
no H.
No, it's I is what? It's the inclination, it's the angle between the, yeah, it's the angle between the two planes, right? Equatorial plane and the orbit plane. If both the planes are the same, then I is 0.
Mhm.
You understand? If it's a polar orbit, what is the I angle? Huh? 90 degrees. You got it? And then it can go maximum to 180, right? So what happens is, if you have this, right? If this is your equatorial orbit, equator, this could be your equatorial orbit, right? This is 0 degrees, and if it is this way, it is 0 degrees. If it is this way, it is 180 degrees. You understand? I has a range of 0 to 180. What happens is,
I don't see how it could be 180 though, because it's still at the same. Still.
so we are going by this, right? If this is your equatorial plane, okay? If this is your orbit, how do you define inclination?
It's angle.
This is coming here, right? H. Right? And this is K. Right? This is your inclination. If I do this, where is H? You got it? Because this is H. It is going this way now. You understand? Now the inclination is 90 plus that. Does that make sense? What happens is, if Earth is rotating like this, orbit is also in this direction. What orbit is that? That's a prograde orbit. You understand? If the Earth and the orbit are in the same direction, it's a prograde orbit. Does that make sense? You can launch in the opposite direction as well, right? How do you go from Japan to California? You take the Pacific Ocean, or do you take the Atlantic Ocean? You cannot take Atlantic Ocean? You can't go over Atlantic Ocean, right?
It's going to take longer.
It's going to be a retrograde. You understand? Earth is rotating like this, you are going like this. You get it? If you take a Pacific, you're going the same direction. It is prograde. You understand? So inclination, if the direction changes, it just becomes a retrograde orbit. You understand? So the inclination, you can just say, depending on whether it's a prograde orbit or a retrograde orbit, it will be 0 to 180. You get it? What is the issue with retrograde orbit? When do you get into a retrograde orbit? Huh? When you're trying to? Or if you don't want to be there for too long, you get into a retrograde orbit. If you want to come down really fast. You understand? Because atmosphere is also
Going in the direction.
in that direction. So it's opposing, right? There is much more. Yeah. So you'll fall down much easier.
Other things are retrograde right now. Other things are retrograde.
Not a whole lot, but there are. If you want to, the reason you want to put something in a retrograde orbit is you want to get done with the mission and crash it, or not crash it, but burn it in the atmosphere. Okay. So keep in mind this. So you know how to calculate this now, right? Now, what is the next angle you are going to calculate?
Cosine or sine wave.
Think about 1, 3 divided by 2, 3.
What do you mean by think about
Cell 1, 3 divided by cell 2, 3. What are you going to get? Sine omega, right? Sine I divided by cosine omega
Sine.
sine I.
So that'd be
This will be
tangent.
tangent omega, right? And tangent omega is what? 0.6264 divided by
negative 0.
negative 0.65178.
Why? Okay,
Hmm?
why are you choosing those cells instead of the ones that you
Hmm?
I said, why do you choose those numbers like instead of the ones you right?
These two
Yeah.
correspond to sine omega sine I, cosine omega sine I. Does that make sense?
I thought you did the
Cell 1, 3 is sine omega sine I.
okay. I'll do that.
Cell 2, 3 is second row, third column is cosine omega sine I. Okay? And I've just substituted those values. Tell me where this angle is.
From the node to the parity, right? Or from the satellite.
From 180
Where
to
we
270.
go about from here? Oh, that's in
180 to 270. Right?
it goes
Here?
Somewhere in there. Well,
no, that's you got some with small negative gap, or you got some with wide everything on 90 to 180 is a line of nodes in your parity. It's jump from 90 to 180. Isn't it? Then quadrant 2.
Is it in 2? That is exactly the question. Try to understand the question. Before you jump in, try to understand the question and think about it. Where can it be?
2 or 4.
2 or 4? Why?
Because those are the
Why can't it be here?
They're all positive.
Okay, this would result in negative, right? It cannot be here,
It's positive.
right? It has to be here or here.
But isn't cosine negative?
Huh? So tell me,
So shouldn't it be just in sine?
is it here or here?
You mean 2?
2.
It will be in 2, right?
Alright.
If you do this in calculator will always give you this. It will convert this to, you understand? Mathematically you have not changed anything. You always have to use this judiciously. You understand? Don't just you cannot use calculator for this. Does that make sense? Because this is going to be on the exam.
So it's sine wave.
Would you explain why that is that the second quadrant now?
So omega, right?
Yeah.
Sine of omega is what? Is it positive or negative? This is sine of omega.
Oh, yes.
It's positive. Cosine of omega is negative. You understand? Tangent of omega is negative. This will be negative, right? Here, sine of omega is positive. Cosine of omega is tangent of omega is negative. That is the quadrant.
Oh, okay.
So it has to fit all of them.
It has to satisfy. If you do your calculator will convert this to negative.
So you can see it kind of like X and Y, sine Y.
You have to make sure you put this in the right quadrant, okay? A similar case will happen if, let's see if there is a case. This is just an example. You could have something like tangent omega equal to negative 0.62264 divided by negative 0.65178. Where is this angle?
Yeah, in the third quadrant.
Huh?
In the third quadrant.
It's in the third quadrant, right? Everybody gets that? This is the third quadrant, right? Sine omega is negative, cosine omega is negative, but tangent omega is positive. What will the calculator do?
It'll make the entire thing positive?
It will just do this, right?
Yeah.
Where is this angle?
It's in the first
Oh,
quadrant.
person.
It will put it in the first quadrant. If you give me this as first quadrant angle, you'll get 0 points.
So how do you actually find the number?
You have to look at it and add 180. Add or subtract 180. You understand? Does that make sense?
Let me look at it and ask what we add.
Whatever omega value you get, so you're going to do this like this, right? Omega equal to tangent inverse negative 0.62264 divided by negative 0.65178. What will the calculator give you? Tangent inverse of 0.62264 divided by 0.6365178, right? So omega will be between 0 and 90 degrees, right?
But you need it to be between.
It has to be between 180 and 270. How much do you add?
180.
If it is 0, you add 180. If it is 90, you add 180 to get 270. You understand? You need to understand this.
One more time, my phone dropped, like you said, the tail end. If it's 0, you add 180.
If it's 0, you add 180.
If it's 90,
You get 180. If it's 90, you still add 180, you get 270. You get it?
So basically, you just kind of need to know what kind of quadrant you're supposed to be in.
And then you add whatever is needed. So the idea is, or see, you have to always learn how to think. Don't tell me what to add. I'll tell you what to add. But if tomorrow if somebody asks you, why are you adding? What are you going to tell them? Because I told you so. You have to think. If you think, you'll get it, and you'll get it for the rest of your life. Right? Do you want me to give you a fish, or do you want me to teach you fishing?
You can fish every day.
You want me to give you a fish?
If you give me fish every day, then yes.
Or you give me a fish.
I'm not going to give you
What?
Joshua thinks he's smart.
I do think I'm smart, but really I'm dumb.
Alright. Okay, you're clear on this, right? Now the final angle is you do cell 3 1 divided by cell 3 2. What is this?
Sine I, sine omega,
Sine omega
divided by negative
divided by negative
sine I cosine omega.
sine I negative cosine omega, right? So this cancels. What are you going to get?
Yeah, sine omega over, or it'd be, it'd be tangent.
Negative tangent omega is equal to what?
0.86603
0.86603
divided by
divided by negative
0.05.
0.25. Okay. Again, this angle, now, where will this angle be? According to this,
It'll either be in the second or third or fourth quadrant.
Once we find all of these subscripts, like I, omega, small omega,
they are not quite subscript, they are angles.
well, the angles, we then go back and plug it in to find the remaining portion.
No, you don't have to do the main matrix. I won't give you that. I will only give you that matrix and I'll give you this matrix and I'll ask you to, I'll tell you classic Euler sequence. Classic Euler sequence is 3 1 3 cap omega I small omega. What is this sequence? The next one, your pitch rule.
3 2 1.
Your pitch roll is 3 2 1. And angle will be something like alpha beta gamma or gamma beta alpha. And then I'll give you the matrix accordingly. You have to figure out what to use, how to find out and find those angles. All you're doing here is finding 3 angles. Finding 3 angles, that's all. Does that make sense? You want to do that?
Yes, sir. Find 3 angles, yeah.
Any questions?
So, y'all pitch and roll is made up of what again?
Yaw is what? What axis is yaw?
See?
Or it's rotation of the z-axis.
C is 3, right?
No.
In our connotation, it is 3, right?
Right.
Pitch is what? 2. Roll is 1. So it is 3 2 1. By angle, alpha beta gamma or gamma beta alpha, depending on what you. The classic Euler sequence is the only one which is specific in that it is 3 1 3 cap omega I small omega. Okay, everything you can change the way you want. The sequence cannot be changed, of course. If you say yaw pitch roll, it cannot be 1 2 3, right? Yaw is defined as 3. Pitch is defined as 2, about 2 or y-axis. Roll is defined as about x-axis or 1. Okay. So I'll give you a matrix. You have to compare and you have to be able to solve off. Okay.
Can we find the yaw roll angle sequence if you don't mind? When we start it, yeah. You just show like how.
Sure, the matrix will look different. I can show you the matrix.
Like, I guess what makes sense is use of this problem.
So this matrix is used for 3 1 3 cap omega I small omega. Okay.
I guess which makes sense just refer to 7 and 8. I guess this.
I'll tell you.
Oh.
I'll give you that matrix typically. Okay. Let me just search here. Your so you see your is show location matrix. Okay. Yeah. What is this? This is
One.
No, never goes that.
One.
It's a
This is
row.
row, right?
Row, yeah.
This is
Yeah.
pitch and this is.
Yeah.
Is this the matrix we are looking at?
It's like flip, I think.
Huh?
It's what?
It's like inverse.
It is what we are looking at. Our rotation sequence is yaw pitch roll.
Right.
The multiplication sequence is roll pitch yaw.
Right.
Right? So what are the angles? This is the. What is the roll angle? A.
Oh, this is okay.
Oh, okay.
Roll angle is A, right?
Right.
You with me?
Yeah.
What is pitch angle?
B.
B. What is
C.
yaw angle? C.
C.
So here, look at here, okay? So which one are you going to use? Which one are you going to first find?
Yeah.
Look there and tell me, Joshua.
You can find
Pitch. Pitch angle. Why so?
It's by
It's by itself, right? You're going to use this and you're going to compare that to the number in that column, number in that cell. Inverse of that. You get it? And then you're going to do, if you do this by this, your cosine B will cancel, right? You get negative tangent A. You do these two, your cosine B will cancel, you get cosine C. Or if you do this by this, you get minus tangent C. So you get all the three angles.
So, the blue column, the whole blue column.
No, this over this.
Right. I'm saying like for the whole blue column, like what is it? What does that tell us? Does it just tell us?
Whole blue column.
Yeah.
It's a blue column. What do you want it to
I was
do?
trying to say like, is it supposed to be like telling, like does it tell us anything? Does that specific column in the matrix tell us anything specific or?
It does. It does tell you something. We'll get to that.
Okay.
I don't think that is.
Important.
It is important, but so here everything is okay. If you look at it, if you take the norm of this, in the sense if you take the magnitude of 1, 2, 3,
Okay.
what do you think you're going to get? See, this is a very wonderful matrix. Okay, this DCM. There are how many elements? 9 elements, right?
Yeah.
If you take the magnitude of the third row,
Mm-hmm.
what do you think you're going to get? Guess. This is guess, pure guess.
The magnitude of the third element.
Just this square, this square, this square. And you can base your guess on this.
Okay. Y'all have input if we need the same magnitude.
Look there.
Oh. So,
Direction.
Huh? What is the magnitude are you going to get? What is magnitude? What will the magnitude? What is it? What kind of quantity is a magnitude? It's a scale. It's a number, right?
right.
What is that number?
A number is. Yeah.
Huh? What is it? R a number?
No.
Number. What number is it?
Radius.
What number it is?
1.
1. It is 1.
Wow.
See, you see here. Look at sine square. Okay, sine square A plus cosine square A, right?
Yeah.
What is sine square A
Oh,
plus
yeah,
cosine
that's
square A?
one.
1. Square root of that is 1. You take this cosine square A, sine square A, 1. You see 1 square plus 0 plus 0, 1.
Right.
1 square 0, 1. 1. 0 cosine square A, cosine sine square 1. 1. This is 1, 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 this is 1. You see that? Such a beautiful matrix.
I wouldn't say beautiful, sure.
This is 1. 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 This is 1.
So it's not one you messed up.
Yes! Now you got the point. See? Yes. That's how it is. Okay? So there is, you have to appreciate this. Okay?
So,
You see that? Everybody sees it? Now, Torres, is it clear? If I give you your pitch roll and if I give you this matrix, you're going to be able to find the angle?
It's actually moving in opposite direction.
We'll just finish off with this.
The next
With sixth one, okay? Try to pay attention here. See what we are trying to do here. Read that. A basis ijk. You have I, J, K, right? And then there is another basis, UVW, alright? The way to align this is a basis ijk requires 3 rotation before it can be aligned, before it can be lined up with another basis UVW. The first rotation is 30 degrees about the first axis. The second rotation is 60 degrees about the second axis. The final rotation is 90 degrees about the third axis. Find the matrix required to transform a vector from ijk basis to UVW basis. What is the transformation matrix between ijk and UVW? Anybody? What is this? If I just ask you this, I don't want the final matrix, but I want you to you remember this, right?
It's a 3.
Yes, you're right.
It's a 3, 2, 1.
You remember this, right? What is this?
3, 1, 3.
It is R3 small omega, right? You with me?
Yeah.
Going from ECI to PQW, you start with 313.
Yeah, I was going to say.
3 by omega, 1 by I, 3 by cap small omega. We know this, right? We have established this. This is given to you over there.
Right.
What is the first rotation?
30
First axis.
around the first axis.
First axis 30 degrees. What is the second rotation?
60 degrees about the second axis.
Yes.
Or 60 degrees.
You understand? To go from IJK to UVW, it says the first rotation is 30 degrees, the second rotation is 60 degrees, the third rotation is 90 degrees.
And we did,
You get this.
and you put the numbers in backwards because
That is how it is. We've been discussing
it's
this.
because you always have to put it in backwards.
We always put it in backwards.
So is that's the final answer right there? Or?
This is the matrix you get. Okay? So you can, you know this, you know how to write these, right? You get a matrix. Now what is being asked is, find the matrix required to transform from IJK. This is that matrix. You get it?
You just plug in the angle.
Yeah. Okay? Now, the second part is, R is this. In what basis is this? In what basis is this? How many bases are there here? Problem number 6. How many bases are there? 2 bases, guys. Okay? It's like just like 2 coordinate systems. Right? What are the 2 coordinate systems? Yeah, that's it. So going from IJK to UVW, you see there. That's specificity. Is this, right? What is this? Yes.
My question is about the first one first. It was, once you set up our matrix, you want us to actually multiply it together to get that, the one big one, or is it okay?
I may not ask you to multiply. If here's the deal, here I'll give you a deal. If I do ask you to multiply, it will only be 2 rotations. But I may ask you to just write the sequence of, identify the rotations and write the sequence.
That's it. That's what we got.
Yeah, if I ask you 3, you have to just write this. Okay? All rotations are important. If you make this UVW to IJK, you mess it up. You won't get points for that, okay? This is what basis? That's not a basis.
What is the IJK?
It is the IJK basis. There are 2 bases there. Yeah? Read that. A base is IJK. A base is UVW. What base is this? Why? It's what's called IJK. Okay? So how do you take this from IJK to UVW?
Multiply by the matrix.
Hmm?
Multiply by that matrix.
Right. So you get, if you do, so R in UVW is equal to what? R UVW IJK, right? And this is R. This is IJK, right? I told you this, you remember? This will cancel, this will cancel. This R will become UVW. Guys, I have your exams, okay? If you want to stop, if you want to wait. Do you have a class or anything?
I've got to run up to you.
Okay. Look at your exams. But did you get this? If you need any explanation, please come by my office.